Welcome. In the final chapter of this course, we are going to take a very brief look at differential calculus of functions of several variables. Let me first set up some of the basic definitions and notation. To begin with, why would be interested in functions of several variables? The fact of the matter is, almost everything in life involves several variables. To take some basic examples related to business, almost every manufacturer makes several different models of their product. These models compete with each other, so their prices affect each other. On the other hand, manufacturers also try to control costs by trying to share parts among different products. So if you think about cars, manufacturers often make what's called a crossover or SU version of their cars, and they share some parts, but other, especially body parts, are not shared. And depending on the price of the different versions, consumer may select one or the other. So in effect, models from a given manufacturer as well as different trim lines of a given model all compete with each other even if they are from the same manufacturer. Costs also tend to vary based on other things because sometimes factories make more than one model and they might switch back and forth between different models depending on the expected demand. Everything often involves, in fact, dozens of variables. It turns out for calculus, almost all the complications of functions of several variables already appear with functions of two variables. But the algebra is shorter, is more manageable if you do it by hand. So in this course, we will concentrate on functions of two variables. As we go along, I will make some remarks about what happens if you have more than two. But if you have more than two, and certainly if you have several dozen, you really need calculating machines or computers to do anything serious. Most of the things having to do with pre-calculus material looks very similar to what you did in 1130 or high school pre-calculus. In particular, we are going to be dealing only with functions given by expressions. For such a function, I have to take a domain consisting of just those numbers which I can substitute. But if you have two variables, you have to have one number to substitute for one variable, another number for the other. So if you have a function of two variables, x and y, then I have to tell which number is for x, which number is for y. We use this by the order. Write the function as f with x and y in parentheses in that order. Then I will write f of 1, 2, meaning that 1 is substituted for x, 2 for y. The domain will consist of all ordered pairs, which, when substituted for the variables, gives a well-defined arithmetical expression. And the value of the function is that expression. So this is basically the kind of functions we'll be looking at, so we won't worry about complications given by other types of functions.